Good day, everyone. Today we are going to study further of real-time system analysis using SimSo software. Previously, we have learned about the background of SimSo software. Hopefully, you already installed in your computer. So this is a link, and there are some explanations. So you can go to this website and download it if you haven't, because we're going to use this software for our coming quiz. Okay, and so these are example. So let's say we are given 5 tasks. Okay, 1 2 3 4 5. So the first one is the period, and so on and so forth. Okay, so by default we assume that the value is in millisecond. So now I'm going to show you how to key in this information to using the SimSo software. So this is what you're going to see when you open your SimSo software. Okay, it's an unsafe. We don't know the name, so let's say we save it. Okay, we save it using a demo example. Okay, demo example. Save. So here we go. There's a name demo example. Okay, next execution time of the CPU is the WCET, the worst case execution time. So the scheduler. So let's say we use our famous static scheduling strategy, the rate monotonic, the RM. Okay, so we select RM and the processor we add 1. Okay, and because it's a mono or unit processor. After that, we're going to add the tasks. We have 5, so we add 5. 1 2 3 4 5. Okay, so after we add our task, so we're going to key in the period according to the given value. Okay, so first I think the period. Okay, 9 18 36 6 and 12. So the name is okay, even though there's a T1 T2 is still understood. So the deadline is 6. If the deadline is not given, so we will make it same as the period. Okay, 10 10, and then we have add and add. Okay, after that we want to fill our CPU time, the worst case execution time. We have 0.5 and then 1 Okay, so after that we just click run, so we have the result. So it's quite okay because the CPU only 0.44 or the 44%. And then here we can see the task performance, the computation time. And the computation time basically is the CPU time, as you can see here. And then we can see the response time. Response time, there is a minimum and a maximum. Okay, so it depends. So for example, the task 4, if you see the task 4, if based on RM is the what is a higher priority. Okay, so that means there's no any preemption for the task 4. So that's why if you can see that the complete time or the response time is the same, so it's 1 only. Okay, it's not any preemption. So after that we can see the task 3. Task 3, the complete time is 4.5, maximum also 4.5. Okay, that's because it's a least important task. So that means you need to wait all the tasks complete before you run this one. Okay, and then here you also can see when the task start and end, and then compared to the deadline. Okay, So all can be studied using this software. Okay, so and then the activation diagram is the gun. Okay, so you can plot CPU or without CPU. So okay, so this is our gun chart or the activation diagram. So we're going to make it bigger. So make sure you print out the full screen. If you are required to submit this one for your assessment, a complete cycle. No, this one is more than one complete cycle. So the first step should be the calculate the hyper parameter as usual. So somehow now we run too fast already. So the step one, as usual, the hyper period. So what's the hyper period for this case? So you can use this common multiplier. Okay, and then you should get answer 36. Correct? Okay, 36. So how are we going to get 36? This common multiplier of 9, 18, 36, 6 and 12. 36. Because the task 1, okay, we have 1 multiplied to 3 multiplied to 3 or 3 to power 2. So we get the period of 9. Okay, 9. Okay, period P1. So same thing for our P2. So P2 is what is the 19? It's 18. 18. So 18 equal to 9 multiplied by 2. So this this multiplier. And next P3. P3 is 36. 36 we need to 2 to power 2. Okay, am I correct? And then we have 4. 4P4 is 6. 6 is this only. 2 multiplied to 3. And then we have 12 for our task 5. So task 5 to power 2. And then we're going to pick the highest. So now the highest is 3 to power 2. Okay, 3 to power 2, 3 to power 2, 2 to power 2, and 2 to power 2. This one multiplied to 3. Okay. So the least common multiplier will be 2 to power 2 multiplied to 3 to power 2. So it's equal to 4 multiplied to 6. Okay, 9. Okay. Okay, so it's 6, 4 multiplied to 9, you get 36. So this is the solution that you should be provided if you are required to find the hyperperiod using this common multiplier. So that's mean every 36 the pattern will repeat. So we can zoom in further. Okay, when we zoom in further, you can wait, okay, so we can put a frame here. Okay, every 35 and 36, so we will see the same pattern. Okay, so next now is the 72. So you even can see here is the what, the release time. Okay, the release time, the arrow and the arrow point out is the release time for all the tasks. All are at the same. So this is the what, the hyper period. Okay, so the pattern will keep repeat. So now we need to change. Okay, we need to change the what, the period, so that we can plot one complete hyper period only. So we need to go to where we need to make this one smaller, so we can see another window. Okay, to restore the window, so we go to the model data, and then the general. So the duration is too long, so we know it's a 36. So okay, we change to 36 millisecond, and then we run again. We see the activation diagram again. Okay, zoom in. Okay, much clearer, as you can see. Okay, we can save this one in the, so you can submit by save the Gantt chart. So we save as, for example, quiz, no quiz, this is a demo example. Okay, settle. Okay, next we want to study the state of the task, the state transition. We want to figure out what is the state of each task. So hopefully still remember this this lesson. So basically we only have 3 or 4 steps only. So the ready, the running, the block, okay, or the suspender. Okay, we have 4. So at the time 0, okay, at time 0, so apparently all the task is released. Am I correct? So all is the release. So apparently all of them are ready. Ready, 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 ready. But the task 4 actually is not ready, but is actually in the running state. So that the task 4 is running at time 0. So we have a ready, ready, ready. So this is the first analysis that we can conclude at time 0. So next we go to time 4 millisecond. Okay, at the time 4 millisecond, so this is a 4 millisecond. Okay, so at 4 millisecond we find out that the task 1 has what, the task 1 is completed. So when a task is completed until the next release time, so actually it's in the block state. So the task 2 same as well, it has been completed, so it's in the block state until the next release time. And the task 3 is in the running. Okay, and then the task 4 is completed and the task 5 also completed. So apparently these two also in the block stack. Okay, so the third example is if the time is at 2.5 milliseconds. So at the 2.5 millisecond, task 1 completed, so it is in the block stack, and the task 2 haven't been completed, so it's in the ready stack. Okay, it's waiting the CPU. Okay, the task 3 also not completed at the time 2.5, so it's in the ready stack. The task 4 completed, so it's in the block stack, and while the task 5 is in the running stack. Okay, so hopefully these three demonstrations help you to understand how the stack transit. So next, the analysis is about the response time. Okay, total how long the task need to be respond or to be completed. So basically, it's a time complete. Okay, minus the time release or release time. So for example, the task 1, the release time is time 0. So the time complete is when it's complete all the CPU. So basically we know that is 2 millisecond. Okay, 2 millisecond. So for the second round, there's not any preemption, or there's not any block time, so actually it's direct executor, so it's 1 millisecond. Okay, and then we go to see the third release time until complete, still 2 millisecond, and then the final round is 1 millisecond from release time to complete time. So the task 2 from release to complete, okay, it takes how long? 4 millisecond. Okay, 4 millisecond. Okay, and then the second release time to complete is 2.5. Okay, is faster a bit, 2.5 millisecond. Okay, that's all. 2 round. The third task 3, complete is 4.5. Okay, 4.5 millisecond. 1, 2, 3. So this one is 3.5. The task 2 is no 4. 3.5. Okay, 4.5. Okay, only one. Okay, only one round. And then the task 4 look like is the first priority. As you can see that after release, the task is executed directly. So it's 1 millisecond. Okay, and then 4 millisecond. Task 5, we have 1, 2, 3 millisecond. First round 3 millisecond. Second round become 2 millisecond. 2 millisecond. And then the last round also 2 millisecond. Okay, so from here that we can conclude that the mean is 1 millisecond for our task 1, while the max is 2 millisecond. Okay, the same analysis or the result can be stated and the rest of the task 2.5. Okay, and then 3.5, and so on. Okay, so this is a result. So the thing that I want to highlight is the task 3 and task 4. So since task 3 and task 4 both we only can observe one response time is 4.5 and 1 millisecond, so the minimum and maximum are the same. So minimum 1 millisecond, maximum 1 millisecond. Okay, and then we can open our software. Okay, you select the result, and then general you create the task, the tab task. So here we go, you can see the minimum and maximum is the same as what we observe from the chart. Okay, so here this one will help you to verify whether you get the right answer or no. Okay, so the computation time is a CPU preemption. There's not any preemption. Obviously, we can also from the activation diagram as well. There's no any preemption in this example. So in summary, we have calculated the hyperperiod using this common multiplier for 5 tasks. Okay, and then we have plot the activation diagram using the SimSo software, and we also analyze the state and also the response time of each task. Okay, thank you.